Hi and welcome to this segment where we are going to look at how to compute an inverse using the Gauss-Jordan elimination. Okay, so the procedure is as follows. One, we are going to start with our matrix A, okay, which we are going to augment with the identity matrix, and then we are going to perform a series of Gauss-Jordan elimination steps, okay, to come up with a system where we have the identity now shifted to the right hand side, augmented with a matrix which will turn out to be the inverse of A. Okay, so if we'd like to check that indeed this is the inverse of A, we can do that by computing A inverse. It should be the same as A inverse times A, and it should be able to give us the identity matrix. Okay, or indeed you can use our MATLAB, okay, and get a matrix A, okay, then use MATLAB to find its inverse and then compare with the method we are going to do here. So let us continue with an example here. Okay, and what do we have? Let us say that we have our matrix A, which is given by 1 1 1, and then we have 1 2 2, and then we have 1 2 3. Okay, so we have the matrix and augmented with the inverse. We are going to have the matrix 1 2 2 1 2 3, and then augmented with the inverse 1 0 0 0 1 0 0 0 1. So the next idea is to carry out a series of Gauss-Jordan steps such that we now have the identity on the left hand side, and then whatever matrix we shall have on the right hand side will turn out to be the inverse. Let me remove that because we have not yet reached that step. So here I am sure you are already familiar with these steps here because we have done this countless times in previous videos. So here we would like to, of course, to make that a 0. And how do we make that a 0? Of course, we can say row 1, we replace it row 1, okay, and then we have minus row 1 plus row 2, and then we put the result in row 2, which will have minus that and that, and we get a 0, and then minus 1 and add 2, we get 1, and then a negative and add, we get a positive, we get negative and add, we get a negative, negative and add, I think we have a 1, negative and add, have a 0. Then in row 3 it's still the same, minus row 1 plus row 3, and then we put the results in row 3. So negative and add, we get a 0, negative 1 and add 2, we get a 1, negative 1 and add 3, we get a positive 2, negative 1 and add 0, we have negative 1, then 0 and 0, we have a 0, and then a 0 and add 1, we have 1. So next is, so what is the next thing? We make sure that we also make this a 0. Okay, so for that step, row 1, we go back to row 1, and then row 2 is into row 2, and then how do we make this a 0? We can say minus row 2 plus row 3, and then we put the result in row 3. We make this a negative and then add here. So we have 1 1 1, then we have 1 0 0, then we have 0 1 1 negative 1 1 0, and then we have a 0 multiplied by negative and add, we have a 0 multiplied by negative and add 2, we get a 1 multiplied by a negative, that becomes positive 1, add negative 1, we get a 0 multiplied by a negative and add, then multiply by a negative, that remains 0, and add, we have 1. Okay, so what next? We have to now make this a 0. Okay, we have to make sure that that is a 0. How are we going to do that? Okay, let's see. Row 1 we place in row 1, and then row 3 we place it in row 3, and then what else? And then we can say minus row 3 plus row 2, we put the result in row 2. We are going to multiply by negative and add here. So these ones here which are untouched, we first write them down. Okay, row 3 is also untouched. This is 0, this is negative 1, this is 1. So multiply by negative and add, we have a 0 multiply by negative and add, we have a 1 multiply by negative and add, we get a 0 multiply by negative and add, and change, multiply by negative, that becomes 1, and then add 1, we get a 2, multiply by negative and add a 0, we have negative 1. Okay, yep. So what next? The identity 1 0 0, it's supposed to be 0. We have to make sure that this is a 0, and we also have to ensure that this is a 0. Okay, yes. So what can we start with? Okay, let us go one step at a time. Maybe we can let us make this a 0. Of course the order here doesn't matter, and many people can have different ways of reducing this, so don't take it that the order I'm following is what you should have to follow. It's just preference. So this is 0 0 1, so we are not changing that row. And then anything row 2? No, nothing. We are not changing anything. So this is 0 1 0, this is negative 1 2 negative 1. And then what are we doing here? We are saying minus row 3, you multiply by negative and add the entry here, so plus row 1, and then we put the result in row 1. So of course a 0 and a 1 doesn't change anything. This is 0 and 1 does not change anything. Multiply by negative and add, that will become a 0. Multiply by negative and add 1. Multiply by a negative, that becomes a positive, and add 0. Have 1 multiply by negative, and then add a 0, that becomes negative 1. Okay, so next is we have to make this a 0. So finally we can say row 3 remains in row 3, and let me see, row 3 remains row 3, and then row 2 goes to row 2, and then here we can say that minus row 2 plus row 1, we put the result in row 1. So here we have 0 0, we have 1, we have 0 negative 1 and 1, 0 1 0 negative 1 2 negative 1, and then here we multiply by negative and added. Okay, so this became a 0 multiplied by negative and add, remains a 1 multiplied by negative and add 0 multiplied by negative, that becomes positive 1, and add 1, we get 2 multiplied by negative, this becomes negative 2, and add 1, we get negative 1, and then multiply by negative, that becomes a positive, and then multiply negative 1, we have a 0. So finally you see that we have, this is now the identity, and then we have another matrix here which is going to be the inverse, and then we're going to say that therefore A inverse is given by 2, -1, 0, -1, 2, -1, 0, -1, 1. Like I said, the procedure is correct. If the answer here is not correct, then it means that the error, I have made the error in the Gauss-Jordan elimination. But there are very many ways of verifying this, and you can just punch it into MATLAB and check it out. But if I see according to the lecture, the resource book, I think it is correct. Yes, I think it is the same. So if you so need to check, you can always check out and compute A times A inverse, and then compute A inverse times A, and then make sure that it gives us the identity matrix of order 3. Okay, yep. So thank you, and next time we shall start with looking at a few more properties of matrix inversion.